For this lesson, we're going to take a look at radicals. So we know that for square roots, all positive numbers have two square roots, a positive one and a negative one. The positive square root is the principal square root, which we represent with just the radical symbol. The square roots of a perfect square are going to be rational numbers, so the square roots of 16 are 4, negative 4. But the positive square root, or principal square root of 16, is only 4. The square roots of a non-perfect square are irrational. The square roots of 17 would be the square root of 17 or the negative square root of 17, but this would be the principal square root. For cube roots, the way cube roots work is all positive and negative numbers have one cube root, denoted by the symbol of cube root. The cube root of a perfect cube is a rational number, like 1,000. The cube root of 1,000 is going to be 10. The cube root of negative 27 is going to be negative 3. The cube root of a non-perfect cube is going to be irrational and would just have to stay written like this. So, if I'm looking at roots, then I could say that if 4 times 4 is 16, the square root of 16 is 4, or the principal square root of 16 is going to be 4. 5 times 5 times 5 is 125, so the cube root of 125 is going to be 5, or I could write it as like this with the radical symbol, cube root is 5. If 2 times 2 times 2 times 2 is 16, then the fourth root of 16 is going to be 2, or the principal fourth root of 16, just the positive version, is going to be 2. If 10 times 10 times 10 times 10 times 10 times 10 is a million, then I could say that the sixth root of 1 million is going to be 10. So if that's true, then I could just take the square root of 49 and say it's going to be 7. If I take the cube root of 64, the number multiplied by itself 3 times to get 64 is going to be 4, and it's going to be the negative version of this. A number multiplied by itself 4 times that equals 10,000 is going to be 10. If I'm doing it for a fraction, remember I need to take the fifth root of the numerator and of the denominator. Well, 1 multiplied by any number of times is going to be 1. A number that can multiply by itself 5 times to make 32 is 2, so it's just going to be 1/2. If I try and take the fourth root of negative 16, I can't take an even root of a negative number. It's not mathematically possible. And if I take 2 times the cube root of 125, that would be the same as 2 times, well, the cube root of 125 is going to be 5, and 2 times 5 is just 10. Now, on all your calculators, there's going to be an x root or an xy root function. Depending on the calculator you're using, the steps might be different, but typically what you have to do is you need to write what the index is, or the number on top of the radical symbol, first in your calculator. Then you're going to use that x root button, and then you're going to write the radicand, or what's inside of that root, into your calculator. So if you're doing it properly, and you put 5 and the x root of 1024, then your answer should be 4. If you are taking the seventh root of negative 2,187, then your answer should just be negative 3. If you're taking negative 3 times the fourth root of 50,625. Be careful, when you put this in your calculator, you're going to say -3. Don't forget to do the multiply, and then 4 x root of 50,625. So you're multiplying it out properly. And if you do this correctly into your calculator, you're going to get -45. If I'm putting a fraction 1 into my calculator, then what I'm going to do is I'm going to put 3 in the x root of bracket 216 divided by 125 and close the bracket to make sure that this is all inside of that radical. It's going to be the same as taking the cube root of the numerator and the cube root of the denominator, and then use the math frac to turn it back into a fraction, which means that if you did this properly, the cube root of the top, cube root of the bottom should be 6/5. If I'm evaluating to the nearest hundredth, I'm doing the same process. I'm just going to round it to 2 decimal places. So the fifth root of 125 is approximately 2.63. The sixth root of 0.5 is approximately 0.89. And for the last one, be careful how you do it. You're going to put in bracket 2 divided by 3, close the bracket, and then you're going to have times the fourth root of 1,000. And if you did it properly, you should get approximately 3.75. Now, any number with this root sign is what we call a radical. A radical is made up of 3, sometimes 4 parts, where a radical has the number on top of the radical symbol or root symbol, which we call the index. It's going to have that radical sign that looks like that weird little check mark, and then it's going to have the radicand, which represents the number inside. This entire thing is called a radical. Now, sometimes we can also have, like we see up here, a number beside the radical. Just like if it's a variable, we'd call that the coefficient. One thing you probably already know is that if we have a radical and we write nothing up in that top spot, it's always assumed to be the number 2. So if it doesn't have anything written, there's an imaginary 2 that's sitting up there. So if I'm identifying the index and the radicand, the index for the first one is 5, the radicand is 75. For example B, the index, if it says nothing, is 2, and the radicand is that 50. For the last one, the index is 3, the radicand would be that negative 1/10, and that 5 would be the coefficient. Now, one of the important things you need to know is that if I have a square root times a square root, that's the same as if I took both the radicands and multiplied them by each other and then took the square root of them. Same thing is true if I took the square root of 9 divided by the square root of 4. It's the same as if I took 9 divided by 4 and then took the square root of that answer. This does not work if I try to add radicals. Sorry. This does not work if I try to add radicals or subtract radicals. That is not how you combine them. It only works for multiplication or division. So we can simplify that to state that the square root of a times the square root of b is the same as the square root of a times b. Or the square root of a divided by the square root of b is the same as the square root of a divided by b. So if I'm stating if it's true or false, then root 3 times root 6 is equal to root 18. Well, 3 times 6 is 18. This is true. If I took the square root of 20 divided by the square root of 10 is equal to the square root of 2, well, 20 divided by 10 is 2. So this is also true. Is the square root of 16 plus 9 the same as the square root of 16 plus the square root of 9? No. It doesn't work for addition or subtraction. So if I'm simplifying these, then I could say that the square root of 8 times the square root of 3 is equal to the square root of 8 times 3, or the square root of 24. Square root of 7 times the square root of 3 is equal to the square root of 21. The square root of 50 divided by the square root of 10, 50 divided by 10 is going to be 5. So it's just the square root of 5. When I get to example D, the square root of 100 divided by the square root of 2, well, the square root of 100 is 10, so this would just simplify to the square root of 10 over the square root of 2, and 10 divided by 2 is going to be 5, so it's just the square root of 5. If I'm expressing something as a product of radicals, I just need two numbers that would multiply to the radicand. So what's one way that I could get 77? 77 is the same as 7 times 11. So if I'm representing it as a product of radicals, it would be the square root of 7 times the square root of 11. How can I get 27? 3 times 9. So I would say that this is equal to the square root of 3 times the square root of 9. How can I get 40? I could say that it's 2 times 20. I could say that's 4 times 10. All of these are acceptable. I can always split it up into two factors and then just make sure I put the radical sign around them. Go ahead and get some practice.